Today we'll be discussing a recently published paper titled The Effect of Relative Encoding on Memory-Based Judgments by Marissa Sharif and Daniel Oppenheimer. Now I'm going to be honest with you. I'm not a big fan of these authors, and they really haven't done anything new or all that exciting in a while. Plus, I really don't think that the results from the study are all that relatable. Now, the authors start off by discussing how research has shown that we are pretty bad at identifying or estimating the absolute magnitude or total quantity of a stimulus. But we are very good at discriminating stimuli from one another. For example, it is difficult for people to accurately identify the number of dots within a pattern, but we are very good at figuring out which pattern has more dots. Now, this finding really isn't all that surprising since it's pretty obvious that we can make some judgments more quickly and more efficiently than we can make other judgments. For instance, if I quickly present you with this figure and I ask you to tell me how many dots were in pattern B, you may not be able to do so very quickly. But if I present you with the same figure and I ask you to tell me which pattern has more dots, you may be able to tell me that pattern B has more dots than pattern A, and you might be able to do this very quickly. Now, related to this point, other researchers have shown that when assessing a stimulus, people represent where in the distribution that stimulus lies rather than the absolute value of that stimulus by making either an ordinal judgment or an integral judgment. Now, the differences between these judgments are pretty subtle and they may be difficult to keep separated, but I don't really think they're all that interesting because an ordinal judgment refers to people's ability to determine that one stimulus is better than another stimulus, but not by how much. Whereas an integral judgment only suggests that people can determine how much a stimuli or how much stimuli differ from one another in relative terms, but not in relation to absolute standards. Essentially, what this is saying is that people's evaluations are heavily influenced by surrounding stimuli. Now, to further demonstrate that people's evaluations are heavily influenced by surrounding stimuli, we can look at a commonly used circle illusion used within psychology. Now, this illusion is overused and you've probably seen it before, but it demonstrates that despite the orange circles being the exact same size, the circle on the right looks much larger than the circle on the left. This is because we tend to judge circles as being smaller when they are surrounded by larger circles. Now, the takeaway from this illusion is that our judgments are often informed by relative information, such as the surrounding circles, rather than absolute standards, such as the exact size of the orange circles. Now, although our judgments are often informed by relative rather than absolute information, there are often times in which we must make a decision without the help of readily available information. Put simply, it's not uncommon for our judgments to rely on our memories of past information. Now, not surprising, prior research has shown that when we rely on our memories to help us with a given decision, we tend to rely on our initial impressions of these past evaluations. Now, this tends to be more efficient than recalling the details of that past evaluation and then reevaluating all of our options. Now, the authors obviously point out that if our judgments are relative rather than absolute, and if we rely on our initial impressions of a stimuli, then do our evaluations of prior stimulus change after we acquire new relative information? Now, the authors discuss an okay example in which they attempt to try and sum up their research question in a way that you may be able to relate to. Now, for example, imagine that there is a college student who eats mainly dorm food. However, the student is able to occasionally go out and eat at a local pub, and compared to the dorm food, the pub food is among the best food the student has ever had. Now, eventually, the student graduates and is exposed to new, better food sources, which are likely to be much better than the food served at the pub. Now, given the exposure to new, better food sources, how would the student recall the quality of the pub food? Now, to try and answer this question, the authors conducted a series of studies. In the first study, the researchers had participants listen to several song clips at 2 different times and then make evaluations about who they thought was the best singer and who they thought was the worst singer. Now, I think the author's methodology in this first study really isn't all that original because in this study, the researchers had 2 very bad singers, they had 3 average singers, and they had 2 very good singers. Now, participants were randomly assigned to one of two conditions, and this is where I start to have some serious concerns about their methodology, because in the first condition, which the researchers called the T1 top condition, the participants listened to two bad singers and then they listened to an average singer. Now, in the second condition, which the researchers called the T1 bottom condition, the participants listened to two good singers and then they listened to an average singer. Now, the reason why I don't think this is very interesting is because the authors use this methodology to make the average singer look relatively good or bad by comparison. Now, after listening to these individuals, the participants completed a distractor task and were then asked to listen to two more songs sung by average singers. And then were asked to select one singer to be the winner and one singer to be eliminated. Now, what the authors found in the study really isn't that interesting or surprising, and as you can see in this graph, when the average singer was paired with the bad singer in the T1 top condition, the average singer was frequently selected to be the winner. However, when the average singer was paired with a good singer in the T1 bottom condition, the average singer was frequently selected for elimination. Now, the thing that makes these results seem fairly obvious is that the evaluation of the average singer depended on his or her relative comparison to either a very good or a very bad singer, and our initial relative evaluations of a given stimuli don't really change even after we are presented with new information, such as the presence of an additional average singer. Again, these findings are pretty straightforward despite the manner in which the authors assess this methodology. Now, in the second study, the researchers had participants watch toy cars race along the track at two different times and then make evaluations about which car they thought was the fastest. Now, essentially, the authors tried to test their research question in another unique way, but I think their approach to the second study is even less original than their approach to the first study. That's because in this study, the researchers had three different toy cars consisting of a slower red car, a faster yellow car, and a moderate speed black car, which the researchers referred to as the target car. Similar to the first study, participants were randomly assigned to one of two conditions in which they either saw a moderate car race the slow car, the T1 top condition, or they saw the moderate car race the fast car in the T1 bottom condition. Again, the reason for doing this was to make the moderate car look relatively fast when racing the slow car, or relatively slow when racing the fast car. Now, after watching the two cars race, the participants completed a distractor task and were then asked to watch a final car race along the track. Now, the thing that really kind of bothered me about this study is, although they were told that the final car was a different car, it was actually the same moderate speed car as before, and the researchers considered it to be a decoy car. Now, the participants were then asked to rank the three cars they viewed according to their speed. Now, not surprising, the authors were able to find another really similar effect in their first study. Now, as you can see in the graph for the second study, when the moderate speed car was paired with a slower car in the T1 top condition, the participants rated it as being the fastest. However, when the moderate speed car was paired with a faster car in the T1 bottom condition, it was rated as being the slowest. Now, given the simplicity of the study, it's really not that surprising that these results further demonstrate that our evaluations of a given stimuli, such as the speed as a toy car, is dependent on earlier evaluations. And overall, I'm really not that impressed that the authors were able to find such consistent results across these two unoriginal studies. Now, in the third and final study, the authors had participants record the number of butterflies that landed on a certain number of flowers. Now, a really strange aspect of this study is that these butterflies and these flowers, they weren't real, but instead were aspects of a computer program, which, in my opinion, was a waste of the participants' time. Now, for the sake of time, I'm not going to go into the specifics of this study, but I should point out that the results for Study 3 were essentially the same as results from both Study 1 and Study 2, such that participants tend to rely on their memory to make relative judgments. Now, the fact that the results were consistent across the three studies really goes to show that the authors' manipulations were fairly generic and potentially too easy concerning the questions they were asking their participants. Now, as we discussed earlier, prior research has shown that people encode information relative to the context, and when making judgments from memory, people rely on their initial impressions. That being said, I'm not surprised that the current study was able to demonstrate that people rely on their initial evaluations of a given stimuli, even when contextual information has changed at time 2. Now, in 3 separate experiments, people encoded information relative to the context at time 1. For example, an average singer was presented alongside either a very good or a very bad singer at time 1, or a moderately fast car was raced against a slower car or a faster car at time 1. Not surprising, across all 3 studies, the authors found that participants would not update their decisions or their evaluations after being presented with this new information. Specifically, average singers were seen as being the best when initially compared to bad singers, but were seen as being the worst when initially compared to good singers, despite information changing at time 2. And the moderately fast car was seen as being the fastest when initially compared to a slower car, but was seen as being the slowest when initially compared to the faster car, despite being presented with the same car later at time 2. Now again, I don't think it's all that surprising that the authors were able to find such obvious effects using these simplistic and unoriginal methods. Now, in sum, when making memory-based judgments, we tend to rely on the context in which the original stimuli was encoded. Now, although this finding isn't surprising, it is important to mention that we should be aware of this bias because our initial evaluations may bias how we encode later information. Given that many of our judgments are based on memory, additional research using more effective methods needs to be conducted in order to understand how and why people make judgments based on decisions.